Welcome back. You've taken the crucial first step by uncovering the key vulnerabilities of small island developing states. In Module 2, you'll delve into the industrial ecology methods that allow us to more precisely pinpoint and understand these vulnerabilities. Think of these methods as medical tests, a way to see what's really happening beneath the surface. Is the island grappling with resource imbalances? Are there hidden pressures that strain its economy or environment? Let's draw a simple analogy to the human body. We inhale, eat, and drink. Our bodies use a portion of those inputs for essential functions, like generating energy or building muscles, while the rest is either stored or expelled as waste. That's mass balance in action. Mass balance is everywhere, from us humans to chickens. Have you ever watched a chicken eat? It pecks the ground, that's input, uses the food to grow and build muscles, that's stock, and disposes off the wastes. That's output. But here's the fun part. When the chicken grows, it gets hungrier, right? So it eats more, grows more, and disposes off more wastes. This keeps going in a circle, a feedback loop. Now imagine an island is like a giant chicken. It brings in food, fuel, and building materials like cement, inputs, builds roads and buildings, and creates trash or pollution, outputs. These stocks form the backbone of societal infrastructure, delivering essential services such as healthcare through hospitals, education via schools, justice through legal courts, and more, ensuring the well-being and functioning of communities. So, if you want more services, you need to build more stocks. And for that, you need even more flows to supply the necessary resources to build those stock. To understand how materials move through an economy, we use economy-wide material flow analysis. What goes in and what comes out. Why? Because if we don't track it, the island might grow too fast. Look at Malay. Long ago, it had trees and soil. Now it's full of concrete. So when it rains, water can't soak in, which increases the risk of floods. One problem causes another. We call that a cascading risk. For example, unmanaged waste pollutes the ocean, harming marine life and disrupting coastal livelihoods. Another tool, called the physical input-output table, helps us understand and reduce these cascading risks. It shows which part is using too much materials and causing problems for others. Think of it like a city map, where locations are different economic sectors, and the material flows are the routes connecting them. The physical input-output table helps us spot traffic jams and suggest better routes for material flows. That way, we can fix the flow and help the island and the people live better. If economy-wide material flow analysis is like looking at the whole island from the sky, the physical input-output table is like zooming in with a magnifying glass. By the end of this module, you'll have the industrial ecology tools to measure and analyze an island's socio-metabolism. That solid foundation will allow us to evaluate and synthesize deeper insights, ultimately guiding the islands towards the sustainable transformation they truly need. Ready to dive in?